Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Fadli Nauval from the Center for Atmospheric Science and Technology Lapan. I would like to present our research with Tintin Asragil Ari and Asif Alauddin with the title Estimation of Quantitative Daily Precipitation QPE uses Centennial Radar Reflectivity Data in West Kalimantan. Why we conduct this research? Here it is the background of this research. Yeah, okay. As we know, that rain is a variable that is very important for life, but it can also be catastrophic. So therefore, it's necessary to have early detection in estimating the level of rainfall and improving the weather forecasting system to reduce the risk factors causing the hydrometeorological disaster. There are several attempts to measure rainfall, that is using rain gauge, but the rain gauge need for rainfall data is important for analysis of weather and climate condition in area. But the limitation of in situ measurement becomes a problem in fulfilling the need for rainfall data. And then we can use the satellite because satellite has a wide coverage but has very small resolution. So we can use the radar technology, although its coverage is narrower, it has a high resolution, can be installed in any area to area prone to flooding and landslide. Okay, there are three types of weather radar classification: S-band, C-band, and X-band. The X-band, the third one, is much smaller in size than the other two radars, and also McLaughlin et al. 2009 said that X-band seems locus as the weather radar classification. So we use radar X-band. And for your information, our institute, our Center for Atmospheric Science and Technology, LAPAN, proudly presents Santano radar. So what is the Santano? Santano is a spatial event monitoring system using Bruno 1932 marked to marine navigation data technology. With the specification, you can all see the parameter and specification here. And then, however, unfortunately, this radar still has several shortcomings that make it unable to directly monitor rain intensity or rainfall rate. So it can be seen that the objective of the study, exactly the estimation of quantitative rainfall QPE, is daily rainfall in particular, using radar reflectivity data. And then why we conduct in the West Kalimantan? Because of the availability of rain gauge. And secondly, wait a minute. Okay. And secondly, West Kalimantan is an area located at a point of 0 degrees of the equator, which always gets high enough source of solar radiation, heat energy, and humidity, and also encouraging convection activity and the process of cloud and arrangement to be very high. And then this is the second method. We use quantitative precipitation estimation QPE radar. As we know that a weather radar doesn't measure the rain directly, but measures the amount of energy reflected by particles in one sample volume. The key factor linking the energy reflected to rainfall is the radar reflectivity, or Z. Whether radar receives reflectivity in dBz, which means decibels, yep, decibel relative to Z. dBz is a technical units or logarithmic and dimension and used mostly in weather radar, where A and B are empirical coefficients. And then this is the evolution method. We use 6 formulas: determination coefficient, correlation, or MSE, bias relative, mean error, and NLC. This is the result. Figure 3, this figure shows a scatter diagram between reflectivity of Santano and rainfall of AWS at 7 sites, namely Yambawang, Kakap, Pontianak, Raso, Mandor, Sebadu, and Segadong. respectively. The coefficient of dissemination at Sembawang site is 1, which means that about 100% of rain events recorded by AWS at Sembawang site can be explained by the reflectivity of Santado. According to the dissemination coefficient, the value of the correlation coefficient, or R, between Santado rain matter and AWS rainfall data can be obtained as a square root of the dissemination coefficient value. Thus, the correlation value at Sembawang site is 1. Statistically, the correlation coefficient shows a linear relationship between two variables with a range from -1 to +1. And it also can be seen that the determination coefficient of other sites shows a value of more than 0.7, such as Kakap, Pontianak, Mandor, Sebadu, and Segado sites with the values of 0.9911, 0.99, and 0.96 respectively. This means that the 5 sites about 95% more, 95% of rain events on AWS can be estimated by radar reflectivity of Santanu. On the other hand, the determination coefficient at Rasau site has the lowest value among other sites, which is poorly 0.41 for this for only 14% of the recorded rainfall events on AWS can be estimated by Santanu radar in terms of radar reflectivity. This is the same method is applied to 7 sites in which all data were combined to become a data set. This figure is a diagram of the reflectivity of Santanu and rainfall of AWS at all combined sites. The obtained RWS relation is 0. That we got 0.969 dBz plus 5.55. It means that this value indicates that 75% of rainfall events recorded by AWS can be estimated by radar reflectivity of Santanu. To comprehend the analysis of performance evaluation of Santanu radar, studies was also carried out by determining the other statistical parameters such as root RMSE. Yeah, you can see all this. And this figure shows a block spot of observed rainfall of AWS blue and reflectivity of Santanu. And this is in order to understand the capability of moth data estimating the rainfall events with varied rainfall. The study was identified by comparing the percentage of frequencies of rain events in each rain intensity. So it is noticeable that the AWS tend to not able to determine the rain events with intensity, the rainfall of from 0 until 5 millimeter in almost all sites, in regard with the rainfall over 20 millimeter. And this is the summary. The results show that the Santanu radar data can be used to estimate the rainfall condition in West Borneo. This is evidenced by the statistical value between rainfall of the AWS and radar reflectivity of Santanu in all study sites which are nearby. The results of the data analysis show a pattern that matches the actual observed value. Based on the scatter diagram, more than 75% when events recorded at AWS can be estimated by radar reflectivity of Santanu. AWS has a better capability to estimate rainfall data over 20 millimeter groups in several sites that rather Santanu and that tends to underestimate. Also, the results of the evaluation of the rain data from rain radar of Santanu are possibly detected to predict rainfall data in West Borneo. However, it is necessary to carry out further evaluation regarding the correlation of Santanu rain radar data by using longer observational data and conducting further studies in other areas in Indonesia in order to obtain better prediction accuracy. Hence, the use of Santanu radar in Indonesia will be becoming more efficient and in accordance with what is expected. Thank you so much.